Welcome to our final couple videos in college algebra, and we are going to look at exponential and logarithmic equations in these two videos here. And really all we want to do is solve exponential and logarithmic equations, okay, using various methods. Okay, so let's dive in. We've already been solving these equations, right? So my question is, what techniques have we already been using to solve these equations? So, for example, we have seen something like 3 to the x is equal to 4. We've solved that. We have had, like 3 to the 2x is equal to 1 over 9, right? We've solved that sort of thing. We've had log base 3 of, maybe, let's make this a little bit more interesting, 2x plus 1 is equal to 5. Okay, we've seen all these. These first couple, or the first one and the third one, we've actually just used the tattoo. Okay, so that would be, or really the definition between exponentials and logs. So if we have a to the y is equal to x, that is the same as, that's the mathematical shorthand for same as, log base a of x being equal to y. Okay, so those ones we just use the tattoo. But then this second one, I'm going to use hashtag for that one, we've actually used same bases, same base exponentials. So we would write this side as 3 to the minus 2, and then we set minus 2, or 2x equal to minus 2, and then we go forward with that. So x is equal to minus 1. Okay, so we already have these techniques in our toolkit. So there are a few more that we need to have in case we encounter them in the future. Okay, and so we want to determine the solution set for each of these. And to do that, the first one on the left might look a little bit scary because we have two exponentials of different bases, right? Previously we had same bases, so what do we do with different bases? On the right side we have multiple logarithms. Okay, let's handle the one on the right first, because multiple logarithms, we just finished learning how to expand and condense. And I think for this case, when we have multiple logarithms, that's the expanded form, so I want to work on condensing them. And according to the condensing property, if we have same base logarithms, which I do, I can write a sum as the product inside. So it'd be log base pi of x minus 5 times x plus 3. And then is equal to log base pi of 1 minus 2x. Okay, and now when we have same base logarithms, just like when we had same base exponentials, we can drop them. So that is to say, we have this property here that if we have log base b of f of x, and that's equal to log base b of g of x, then that means, then that's true if and only if f of x is equal to g of x. So if the log bases are the same, set the insides equal. Okay, so then I just end up with x minus 5, x plus 3 is equal to 1 minus 2x. Okay, and then we can go ahead and solve this, and I'll let you pause the video and do that. So I paused the video and finished it. You can double check my work. I got plus minus 4, and then I would report that as my answer. No, right? Remember, oops, let's go back here. So with log equations, we need to check answers. And specifically remember that the log of whatever's inside here, that thing inside, once you substitute it in, it needs to be positive. Okay, so I'm going to check in my original equation. If I put in positive 4, do I get something that's positive inside? No, this first one, right? If I put in 4 here, I get minus 1, so that's not going to work, so positive doesn't work. And then when I check negative 4, well, rip, that doesn't work either. So this one is actually no solution. So neither one of them work, and well, actually it says determine the solution set, so I'm going to write the solution set for x is empty set, or you can do that. Either one, okay? So again, when we have multiple logarithms, just use of the same base, then we're going to use properties of logs to condense. Okay, so if we have logarithms of different bases, then that's a more interesting question. That is pure evil, and I won't ask you that. You'd have to use a change of base formula to work with that. Okay, but anyway, we have this other exponential one that we've neglected. What do we do with this when we have different base exponentials? Well, kind of like this. When we have this f of x equals g of x, right? I can apply a logarithm on both sides as long as it's the same one. So why don't we do that? And what I'm going to tell you is pick a convenient base logarithm. So we notice we have a base of 10 exponential and we have a base 3 exponential. A convenient logarithm in this case would either be a base 10 log or a base 3 log. Base 10 log actually happens to be easier to calculate with, right? Because that's programmed in our calculator, so I'm going to use that one. So if I take the log of both sides, so I literally just write log of the left-hand side and log of the right-hand side. Again, this is valid because I'm doing the same thing to both sides. Okay, now I can use properties of logarithms. Oh, I have powers. Okay, that can come out in front. So 6x times log of 10 is equal to, and then this would be 3x plus 4. I need parentheses, please, for the love of God and all that is good in life. Remember your parentheses, okay? Okay, log of 10, I just know that's 1, so the left-hand side is just 6x. Right-hand side, okay, now this gets to be a little wonky, okay? Log of 3, okay, I want you to take out your calculator. With your calculator, type in log 3. It's a number, right? So this is a number. And you get a nasty decimal for it. Fine, whatever. You can write it if you want. I'd prefer if you just left it as log 3, because what we're going to do with this number is distribute it. Because this would be a lot like us saying we have 2 times 3x plus 4, right? We would just distribute the 2 to both. So as such, we would distribute the log to both. So I would have 3x log 3 is plus 4 log 3, okay? And now, again, if I want to solve for x, I need to isolate all those terms that have x, so I'm going to move the term with the x from the right-hand side to the left, so I would subtract 3 x log 3 is equal to 4 log 3. And now, what do you do with this? You can't really subtract them easily, but they do have a common factor of x. So I'm going to factor that x out. 6 minus 3 log 3 is equal to 4 log 3. Okay. And then lastly, to isolate x, I would divide by this other junk so that x is isolated. So my final answer is going to be x 4 log 3 all over 6 minus 3 log 3. Okay, and that would be the solution. With exponential equations, you don't need to check your answers. If you want to, you certainly can. But all of this is a number, right? Log 3 you can calculate in your calculator and then just number crunch the rest out. Okay, so there we have a couple new techniques. The next page here I'm going to show you, and I'm going to ask you to do one of these in the video, and I think we're going, or in the quiz, and we're going to do this one in the quiz. Okay. The other ones I will write out the start of the solution for each of these, and then you'll have to finish them. All right. So look for those in just a moment here. And here are the starts to each one of these. So in the upper left, bring the x squared down because it's an exponent inside of a logarithm. So that's 3x squared, and then log base 8 of 512 ends up being 3 as you convert that to exponential form, and then from there you can go ahead and solve. Okay, lower left here, you have different base exponentials. Pick a convenient logarithm to apply to both sides, so that'd be log base 10, and then you can proceed forward with that. Here you need to condense it a little bit, so move the power or move the coefficient up inside the logarithm as an exponent. Then you have same base logarithms, drop them, set the insides equal. Here in the upper right, this is just the tattoo. Okay, so know that that could sneak in there as well. Lower right, condense the logarithms, and so here, since we have subtraction, that's a quotient inside the logarithm, and then when you have the same base logarithms on each side, single same base logarithms on each side, then drop them and set the insides equal. Okay, so you're going to have to do the quiz question now, and my hint is, remember the product to sum property to start off. Okay, and with that, that's going to conclude this video.